Hello, everyone. Welcome to today's webinar. We're going to be talking about simulations in science class. So engaging, it's scary in honor of our holiday tomorrow. So as always, tell us what you teach, where you're calling in from, and you know what? If you're dressing up for Halloween, why don't you tell us what your costume's going to be? I am going to be Doc Ock because my 3-year-old chose all of our family costumes. So we will all be different versions of Spider-Man, and I will be the villain for some reason. Right, let's see. No one is going to dress up for Halloween. I don't see anyone in this chat.
I don't see anyone yet either.
Thank you, Ryan. Again, everyone, if you're joining us, I see the participants number going up. So if you're joining us, tell us what you teach, where you're from, and what you, and if you're dressing up, what's it going to be? I know most of us are adults, so maybe we won't be dressing up, but some of us are families are making us tired mom costume. Same, Linda, same.
Oh, Shrek and Fiona, that's cool.
All right, give it another minute. We'll get started. Love it. We have people from all over today. Hocus Pocus periodic tables. Sure, very nice.
Red Riding Hood and the Wolf.
Love these.
I love it too. Oh, Andy's mom from Toy Story.
That's a good one. That is another series that my son is obsessed with right now.
There's a Harry Potter, Hermione.
So right before we get started, let me go ahead, keep telling us where you're from and what you're dressing up as. I'm going to go through some helpful tips to get the most out of this webinar. If you'd like to access closed captioning, just hit the CC button in the bottom tray and then show subtitles. You can participate and make comments at any time via the chat. We will be answering, interacting in the chat as much as possible. You can also submit questions using the Q&A function. We'll have dedicated time at the end of the webinar, so we'll be collecting any questions we don't answer in the chat or the Q&A right away. We will collect till the end. And you will receive a certificate of attendance with your webinar recording via Zoom email. Now we will introduce our wonderful speaker today. Francis is a Sacramento native, STEM specialist and educator, coach, trainer, and speaker who has presented dozens of conferences all over the place. He has also been a teacher, has taught grades 1, 3, and 5, and served as the K-12 curriculum lead teacher for math, science, and technology. During his time teaching, he received many awards, including the Parent Teacher Association Outstanding Teacher Award, which I think is very impressive, District Teacher of the Year, and West Region Curriculum Specialist of the Year. He is also a lifelong member in many teaching associations and councils and has an extensive background in professional development. So we are very excited to have him here today with us. And Francis, I will go ahead and stop sharing and you can take it away.
All right, thank you. Actually, whenever they told me that they were going to use that caption, that bio, I've never actually thought that anyone actually would read it. But anyway, I'm going to go ahead and share my screen. And let me know when you can see this one. So today, when we were first talking about doing this presentation, it was because there was so much interest in seeing what's going on with the science, with the digital simulations in science. So can everyone see that screen? Can you let me know? Awesome, perfect. Okay, so basically what we were going to do today is kind of do some elementary digital simulations and then also some intermediate digital simulations. So some from the elementary grades and some from the middle school grade levels. Basically what I really wanted to do was kind of go, trick or treat. And but the idea was, nah, we're just going to do treats, no tricks today. So today's agenda basically is going to be looking at digital simulation demonstrations for elementary, digital simulation demonstrations for secondary, and then I have a little treat for you at the very end. So these are the ones that we're actually going to start with. Energy conversions, vision and light, waves, energy, and information, just to kind of give you an idea of how they work. The whole purpose of this webinar was because there was so much interest in how can you take these digital simulations and actually use them in your classrooms to reinforce the instruction that's going on. And all of these sims, we call them sims, actually kind of work directly with the lessons. I wanted to share with you a couple of the elementary ones first, and then what I was going to do is take you into the secondary simulations. The secondary simulations that we're going to work on today are going to be metabolism, trace and reproduction, and natural selection. One of my colleagues' favorite ones is natural selection, so we're going to share that one too. So just to kind of get you started, when you actually, what I'm going to leave you with today, that little treat that I have for you at the very end is going to be access to all of these. So when you're going to leave today, you're going to leave with access to all of them. You'll be able to play with them at least for 30 days. That's how long that demo account is set up for. And then if you want additional access, what you need to do is just contact us and we can send them to you. Okay. So let me go ahead and end this show really quickly, and I'm going to take you straight in. When you actually first get into the program, where the digital simulations are, you're going to come to a screen that actually looks like this one. Okay. I'm going to go back to the very, very beginning. So when you're going to actually log in, you're going to see a screen that looks like this. When you're here, all you need to do is click on the science tab. And the science tab is going to look like this one, and it'll take you into the content. What I'm going to share with you, though, is not just the regular content. So this is all the regular content. So this is our kindergarten through 8th grade program that you'll be able to see here. But the idea is that you're going to focus on right up here in the upper left-hand corner where it says programs and apps. The program and apps button, some people call it the waffle grid or the 9-dot grid. If you click on that 9-dot grid, it gives you a shortcut to all the digital simulations. So all the science apps that are right here, and you'll see them. So for example, harnessing human energy, force and motion, metabolism, the ones that we're going to be looking at today are also here. So there's vision and light, and I already have them open up here across the top. So I'm going to share with you energy conversions first. In energy conversions, basically this is a 4th grade activity. What the kids are supposed to do is look at different kinds of energy that are available. They can actually change the energy source. So we have like sunlight, we have the crank, we have fuel, wind. So as they start to go through this, they can see which of these objects would be able to be dragged into this area. Okay, so for example, if I'm using sunlight, I can drag the solar panels in, which is kind of cool. And then I can see what kind of materials or energy sources that I can use. I can use the motor, or I can use the generator. So if I put the motor up here, it'll actually run this motor. And then from that motor, I can actually go into like this generator and then move it over towards maybe a light source or a music player. What I do then is click on the run button, and it actually allows me to see how it's all going to work. Now, basically what I can do now is analyze it and see how it's able to do all the things that it's doing. So the energy that's transferred, so energy in equals the energy that's coming out. So the conservation of energy. The other thing is that when you're looking at this, if I go back to the build, I can actually change the level of sunlight. So there are different ways that I'm able to process this. The other thing, though, if I go back and I'm going to rebuild this, and let's say that I'm using, let's say that I use wind power, for example. I'm going to rebuild this one and say that I'm using the wind power. So if I go to the wind, now I can actually select a different way. So if I use the flywheel, for example, and run it this way, you'll see some energy transfer items as well. So if I'm going to go through it this way, and I can say, let's say that I'm going to put in the ball launcher right here. The ball launcher is right here. It actually saves some of the energy before it actually transfers it over to the ball catcher. If I could put the ball catcher up here, and then I can take that ball catcher and have that one actually power the LED light source, or actually, let me just take it back to the generator first. If I take it back to the generator, and then run that run that light source. The way that this one works now is if I actually click on the run button, it actually shows me, but I have to transfer the energy from the flywheel to the launcher. The launcher is going to actually gather the energy that's actually being and then transferred over. So it spins over, and now it's spinning the ball catcher, and I can transfer that energy to spin the generator to work the light. Again, if I go to analyze, I can see that whole idea of conservation of energy throughout the way that it's set. So that's just one example of how it's set up. A lot of times the kids like to go through and do the crank. The crank is actually one that they actually have to move through and do it. So if I go back and rebuild this one here, and I say, yes, I want to rebuild this one, and I go to that crank. The crank, they actually have to move through, right? So when I'm going through this one, I actually have to crank it to actually make the energy move. So they like that one too. Now, let me just jump real quick to vision and light. One of the things with vision and light, when this one's actually also out of 4th grade, and this vision and light one actually talks about how animals get information from their environment using their senses. The whole premise of this unit was that the kids actually have to determine why this tokay gecko is actually going extinct in this one part of the rainforest. And so they actually do all these different experiments, hands-on activities that lead up to what we're going to be doing with this vision and light simulation. Basically, what it shows is that if the animals can't see their prey, then they're not going to be able to survive. But if they can see their prey, then they can survive. We illustrate it with a hands-on activity that uses, it's called the mystery box. And the mystery box is kind of fun because it's just a plain box with a hole in the side. And basically the kids look in that hole, and if the box is closed and there's no light coming in, they can't see anything. But once you open the box and the light comes in, then you can actually see what's inside the box. What this does is it actually illustrates that hands-on activity. So if I click on start here, I can see that here's my predator, and this is what he's able to see, and here's my prey. You can notice that I'm able to move this light source around. So I can actually change the way that the light is facing, the amount of light. I can change the pupil size. And if I actually run this digital simulation, I can see that actually if the light is going straight down, he's not able to see anything. But if I'm able to move that light source so that it's actually reflecting off of the prey, then he's able to see it and he's able to eat. Okay, so that's kind of like what we're trying to do. The key point of this one, though, is that the whole standard for this one is, can the kids model this? So the idea is they do a hands-on activity using that box with the hole in the side, and then they do the digital simulation. And now what they're supposed to be able to do is go to the modeling tool. And the modeling tool looks like this. So this is an example of the modeling tool. So here's the eye and here's the brain. There's an eraser, and this is called the open box modeling tool because there's also one that's called the closed box modeling tool. And the idea is if I show it this way, if the kids can actually show that the light is going into the box from this light source and the light is actually coming out of the hole from this box into the eye, then he should be able to see the eraser. And if the kids can do this, that means that they totally understand what they're doing. And so that's how we check for understanding. That's one of the key pieces of how this works. So just another example of how we use vision and light to actually teach that concept. And then one more for the elementary grades I wanted to share with you was sound waves. Sound waves, actually, this one's the lesson that this one comes out of is called Waves, Energy, and Information. And the premise for this one was, how do animals like dolphins communicate with their babies in the ocean if they can't see them? And so that's all about how sound travels. And so by using a simulation like this, I can look at how sound travels through air, but not only how sound travels through air, but how sound travels through other mediums like water. So if I actually click on this one, I can see that there's different instruments that I can play, like the double bass. And if I click on this, I can listen to it. But I can also see how the waves move. I can actually turn the waves on, which is kind of cool, right? So like if I'm looking at maybe the cello and I play the cello, it plays a little bit different. You can see the difference in the sound waves. Now, if I play something that's higher pitched, let's say like the flute, you can higher pitch, right? So there's all these different things that they're able to do. And one of the things that they're able to see is how that sound actually travels through those different mediums. Those are just a couple examples of the primary grades. Let me take you into a middle school one. In middle school, we actually have one called the metabolism sim. A metabolism sim, this one's actually all about how the body changes food into energy. The phenomena for this unit actually is there's a student, her name's Elisa. She's feeling tired all the time, and the kids have to diagnose her and figure out what's going on. They actually go through and they run several tests to see what kinds of things that are happening within our human body systems. And so they learn about human body systems, and this digital simulation is to represent the internal workings of the human body system. It's very simplified, but it's very powerful when you start to think about how they're able to look at these different pieces. So if you notice over here, there's healthy body, anemia, asthma, diabetes, a pancreas injury. So there's different things that you can actually apply to this model to see how the human body systems actually interact. One of the things is, like, if I just play this one in the human body systems, you can see that when I run it, I can see what goes on within, like, let's say the digestive system, or I can see what's going on within, like, the circulatory system, or I can see what's going on within the respiratory system. Basically, what happens is they're also able to feed the system. Like, I can feed it a fish, and I can see how that fish breaks down into proteins, right? So you can see my stuff down here at the bottom. And I can see how those proteins enter into the bloodstream. Or I can look at how, if I feed it corn, and how corn breaks down right into those pieces so that they can see those starches and the glucose, right? The other thing I can do is I can actually make the system run, right? I can make it jog, or I can make it run. I can change the digestive enzymes. What the kids always do down here is they always try and kill the system, right? They try and stop the heart, give it a heart attack, and see what happens, right? So there's all these different things that they're able to do. One of the things that they do learn, though, is about cellular respiration. And it's interesting because when you think about cellular respiration, the idea is, how does cellular respiration break down food to provide energy and release carbon dioxide? That's actually the standard for this unit, right? How does cellular respiration break down food to provide energy and release carbon dioxide? So if I look at the cellular level, this is actually supposed to represent a cell in the body, right? And I can make it bigger. I can see what happens when glucose enters into the mitochondria. And I can actually pause it, because I can see that, energy is being released, because you can notice that that mitochondria is glowing. But the other thing that you notice is that the byproducts of that are carbon dioxide and water. And what's really cool about how these programs are designed is that now I can take a picture of this and import it straight into my notebook, actually to provide evidence to support my claim as to what's going on with that student, Elisa. Okay, so the idea is, all along the way, all of these digital simulations are meant to be incorporated into the lesson, actually to advance the students' thinking, and be able to show them and illustrate what they're trying to think about, what's going on within the human body systems. So, this is just another example of how they can take those activities and actually pull them all together. One more actually is traits and reproduction. I want to show you this one. Traits and reproduction is all about the Darwin's bark spiders and Darwin's bark spider silk. So the phenomena for this one is actually, can they use Darwin's bark spider silk to replace human tendons? I love this unit just because, this is stuff that's actually happening right now. Darwin's bark spiders were recently discovered. You may have read about them. Their silk strength is 10 times stronger than Kevlar. So, there's people that are talking about military applications and all kinds of things, like with bulletproof vests and those kinds of things they can do with Darwin's bark spider silk. If you've ever seen the Darwin's bark spider silk on videos, there's like a bunch of them on National Geographic, you see that their webs are like 40 feet long, right? They actually span the length of rivers, and they can actually trap birds in these big, huge nets. The Darwin's bark spiders are actually extremely venomous, so we can't bring them into our classrooms. But what we can do is we can breed them digitally. And the idea in our unit is, can we use Darwin's bark spider silk to replace human tendons? So it's really interesting to see. They actually get to meet a real spider scientist. Her name is Dr. Cheryl Hayashi, and she actually works out of UC Riverside. And it was funny because I actually met one of her colleagues when I was actually doing a presentation, and we were talking about spider silk, and she says, "Hey, is that Dr. Cheryl? Is that who you're working with?" And we were like, "Yeah." And she's like, "Did you know that she actually won the MacArthur Genius Grant?" I was just like so impressed, because I've actually never met anyone that has actually won that MacArthur Genius Grant. but it was really, really cool that, she's actually doing the videos for us on our program. What the idea is that can I mate these spiders to produce the strongest and most flexible silk? And that's what the whole plan is. Now, if you're thinking about this, this is actually the one about genetics. This is genetics. Basically, this is Mendel, Gregor Mendel's actually activity with the peas. But instead of using peas, we're actually using spiders. So it's a lot of fun. You notice up here at the top where it says like silk flexibility, silk stickiness, the venom, the bristles, the size, the body color, and the stripe color. Now, remember what we're looking at is silk flexibility and silk strength. And if you notice up here, it changes when I click on these, it changes what the proteins are. So, and I can see that Greg has low silk flexibility, but I can see also that Otis has high silk flexibility. I can see that Zora also has high silk flexibility. So if I want strong and flexible silk, I should mate these two. And the way that you do it is you actually can just click on the spiders, right? And you can see those proteins that are going to be in there. The way that you breed them is you just click on them and drag them. So it allows me to drag Otis to Zora. And then what I can do is I can create the reproductive cells with these two spiders. I can also mutate the cells, which is kind of cool. So I can change, like if I want to do some mutations in here, I can mutate the cells, or I can simply randomly fertilize, and then I can see what happens with my spiders. I can see what kind of offspring I'm going to have, and here are my spiders. So now I have several spiders here. Actually, all 4 of my spiders have high silk flexibility. I can change it to stickiness to see if they're still going to be sticky or if they're going to be venomous, what their bristles and their size and all that, so I can still see all these pieces. The other thing though is I'm able to move these around, and I can remate them. So if I moved and I wanted to do spider number 3 with Otis, I can do that too and see what those reproductive cells are going to be. It's pretty cool when you start to think about this. I'm going to go back here. I'm going to go back to the very beginning and show you something else. One of the things that's really cool about this, you notice that there's no green spiders in here. I was actually at a workshop one time, and this teacher told me that her kids come in and breed these spiders, and they're doing all kinds of things, looking for different kinds of the size. They want to change the body color. And actually, this one teacher told me, he says, I literally have to lock the doors at lunchtime right now because the kids keep coming in trying to breed spiders. But one of the things that they were trying to do was get green spiders. And and you see in here, we don't have any green spiders. And so it was really unique because what this teacher told me was that these students actually about 13 generations and mutations in the body color proteins, they were able to get green spiders. And so I challenge you, when you guys try this out, I want you to try and see if you can get green spiders. I actually did this in a workshop, and I actually had a teacher do it in 3 generations with mutations at the colors, which was super, super cool. And then they took it a step further and they got 6 green spiders. So that's my challenge to you when you take this to your class, and see if you can actually get those green spiders. Now, let me show you another one. I want to show you one more. Natural selection. Natural selection, like I said, one of my colleagues' most favorite digital simulations. Now, in natural selections, basically what we say about our digital simulations are designed for things that are too small to see or too big to see. Things that happen too quickly or things that happen too slowly, in real life. And so one of the things that we cannot see in natural selection is generations. We can't go into our labs and see generations of animals and how they can change over time. And so with natural selection, basically, we're able to see generations happening really, really quickly. There are different things that I'm able to do. I can change the temperature. I can change the rainfall. I can change the surface color, because, that might make a difference when I'm going through and looking at these different animals. I can look at all the different um, activities. So I can change the height of the trees. These are called australopes. So these are like the vegetarians. And then these are my carnithorns. These are my meat eaters, right? So I can actually change those as well. But basically what happens is this. So what I can do is I can actually change this. I'm going to go ahead and go into my situation here. I'm going to go back all the way through. and I'm just going to jump into, let me just close this for just a second here. I'm going to jump in to run this simulation. When I run the simulation, I can see these animals, but I can't see them very closely. So I can actually zoom in on them. I can see like my australopes, I can see my carnithorns, I can see the trees and how these animals are living through their life. I can actually watch what happens, like this guy just ate that, that guy, right? I can also see that, you know, what happens when they meet each other. Sometimes they'll meet each other, they'll give each other a little hug, and then there's a little baby that appears. I think that's one of the things that the kids love the most. You see how they just kind of gave each other a little hug, and then all of a sudden there's a new one, right? And so they're able to go through all these multiple generations up here. It's kind of fun. You can actually select one and then you can follow it, right? You can see what it's going to do, how he grabs this one and eats them, and go through multiple generations on seeing how he's able to do all this stuff. So he's going to go past it, but I can see, you know, like what he's going to do and how he's going to turn around, come back and get these guys. There's my australopes, and then there's the baby that just came out, and then boom, he's got him again. So there's all these different things that they think the kids like this one just because they get to see like a little bit of everything that's going on within these different generations. Now, this is just, again, this is just a very, very simple simulation to kind of show you what's going on. I just showed you a couple of elementary ones, a couple of intermediate ones. And then I was going to give you a chance to play with these, but they are super fun. They're very, very engaging, and they actually reflect what's going on within the lessons. One last one I want to show you, and actually it's actually here. So basically what I'm going to do is I'm going to jump here and I'm going to go into force and motion. Force and motion also is actually out of 8th grade. And force and motion, this one, what the kids are supposed to do is they're actually, the phenomena in this one is that there is unmanned spacecraft that collects samples from an asteroid belt. And the idea is that this unmanned spacecraft goes out, collects samples, and comes back into the space station, and they analyze the materials that are on the space station. What happens is as the shuttle is coming back and docking with the space station, they lose video and they don't know what's going on for like these 8 seconds. So there's this missing 8 seconds, and the kids have to figure out what's going on. So they learn about, this is all about Newton's laws, and they're talking about force, they're talking about collision, their impacts, all of those different things. But because this is space, our targets are moving, right? And so when you think about giving horizontal or vertical velocity to our targets, the idea is this is kind of like a air hockey table, but I can put these targets up here. So I put this horizontal target, and because this target is moving, I can give it a horizontal velocity. So let's say that I move it and I say, I'm going to give it a horizontal velocity of 5. In order for me to make this object hit that target, it also has to be moving at a horizontal velocity of 5. Right now it's still. And so I can actually hit it with different objects. And you notice that these different objects have different masses. But if I put an object up that has the same mass as this one, actually, I think it's this one here because it looks a little different color. Maybe it's this one, but I can put it up. So this one has the same mass, I can see. And if I give that a horizontal velocity of 5, then what happens is if I hit this, the transfer should allow me to hit that target. And that's what the kids are able to do. The idea is can I actually set this up so that they're doing it that way? The kids actually have a physical hands-on activity that they use to actually create this on their tables. And so they have these launchers and materials that they're able to hit with these pieces. But in order to get that velocity exact, it's easier to see on a digital simulation. So if I run this one now, I can see that I'm able to hit it. If I did it differently, so let me just go back and refresh this. So let's say that I gave this a horizontal velocity. I'm going to rebuild it. I'm going to give this a horizontal velocity of maybe 10. What happens then is that it doesn't hit, right? So when I click on run, now it's just too hard. Or if I actually hit it and it's too soft, if I go back and build it again, and I give this a horizontal velocity of, let's say 3 or 1, it doesn't do anything. right? So it's not going to be able to catch it. So those are the kinds of things that the digital simulations are designed for. You notice that that target is actually moving at 5 centimeters per second, but the object was only moving at 1 centimeter per second. So they weren't going to match, they weren't going to hit. And so those are the kinds of things that they're able to do. Now, remember, really quickly, I'm going to jump back up here to the home screen. When you're first in that home screen, and you're going to land on a screen that looks like this when I give you that access. Now, this is my demo account, so you actually don't see all of these things. What you're going to see is just one simple one up here that's going to say science. It's going to look like this one right here. When you click on that science button, you'll have access to fourth grade or third grade through eighth grade. And the reason is that third grade is where the digital simulations start. So that first digital simulation is going to be here in environments and survival. It's a super fun one. If you look at fourth grade, fifth grade, and sixth grade, you'll notice that all of these actually have digital simulations. So we looked at energy conversions, we looked at vision and light, and we looked a little bit at energy, waves, energy, and information. If I jump to fifth grade, you actually have multiples in here. So modeling matter actually has 2 digital simulations involved. Patterns of earth and sky. The kids love this one. This one just because they can see the night sky, they can see the stars, all of those different pieces. Ecosystem restoration. The digital simulation for this one too, super, super fun. So if you have an opportunity to look at that one, get in there and do that one. And then of course at middle school, we looked at metabolism, we looked at traits, thermal energy. That one's awesome. Okay, so if you have a chance to look at that one, and then of course 7th grade and 8th grade, when you look at these digital simulations that are available, phase change, chemical reactions, all of those digital simulations, plate motion, super fun. And the ones that I showed you in 8th grade were force and motion and natural selection. Waves, light waves, this is one that we always do, but this one is all about how you can bend light. This one here, light waves, let me just share that one with you just really quickly. That one actually is pretty cool because they're able to do different things that they do physically with real materials. So if I go to light waves, which is right here, you notice that they actually have all these different materials they're able to do and use within setting it up. So we have these lasers right here. Okay, and we're going to actually use light bulbs, but the laser is probably the easiest one to use. And then they can put different materials up to see if it penetrates those materials, right? And the idea is that when they're going through this, they can actually run this and see what happens to how the light actually doesn't penetrate. And so there's different things that they're able to do. The idea is within this digital simulation, there's different tasks that they're able to do, simple and complex. Like that one that I was showing you with force and motion, it actually has multiple missions that they're able to do. So these multiple missions actually offer them those opportunities as they start to go through those lessons. It is super it actually gets very, very complex. So as the kids are going through the lessons, they don't just use it once, and it's not a one and done. It's like multiple opportunities to go in and see how all these pieces work together. And it's just to reinforce the concept that they're trying to do to solve that phenomena when they're going through that lesson. So for that unit, for example, you notice that there's multiple missions that they're able to do when they go through all these pieces. Okay, so remember, I promised you the treats, right? So I'm going to end this one here real quick, and I'm going to jump back into the PowerPoint deck that I was in. So right from here, so remember, I was promising you those treats. So here we come. So if you want to just do this now, you can. But basically what you want to do is open up a tab on your computer. If you just want to actually save this for later when you have time to kind of play around with it, you can do that too. What you're going to do is you're going to go to learning.amplify.com, and you're going to click the third one down, which is called Login with Amplify. I made this demo account for you. It's called So Scary because right, it's so scary. So it's t1.soscary@demo.tryamplify.net, and then the password is going to be amplify1-so scary. Okay. When you click on login with Amplify, the screen should change to look like this, and that's where you're going to enter your information. So just remember, third one down, log in with Amplify, T1.SoScare. If you want to take a picture of this screen, that demo account will be active for the next 30 days. And then again, if you want to extend that, just let us know. We're happy to share the logins and those kinds of things so that you're able to do this with your kids in the classroom. Now, I'm not sure how much time of that took. I think we have this scheduled for an hour, but is there questions? Is there any questions that we have that are
Yeah,
coming up?
I'm back, Francis. So if anyone has any questions, please drop them in the Q&A. We did have a couple come in through the chat. So Caroline says that she knows how to access the simulations for her grade level. Will she be able to access all the ones that you talked about today?
Yeah, actually, with this demo account, she'll have access to all of them.
Perfect. And then Christine asked, do the elementary STEMs have different levels? I've never noticed that.
They actually do. So when you're inside the lessons that themselves, depending on which simulation you're in, it'll have different missions too. So basically what you want to do is you want to make sure that you're hitting, let me go ahead and end the show again. What you want to do is make sure that you're hitting that the three lines here, the menu. Sometimes it's just going to be that log out menu, but sometimes what you'll see is that there's going to be different opportunities. So to do different activities, right? So just depends on what your sim is. Okay. So, and you know, like the scale tool and those, some of those, you'll be able to see different things that you're able to do. That scale tool that's in there, that digital simulation that's called the scale tool, that one's used in multiple grade levels just because they're able to do so many things with it.
And Miranda asks, is there anything for first grade?
There actually isn't any digital simulations. The digital simulations actually in our program start at third grade. And at first grade and kindergarten, we simply just have some videos and those kinds of things that they're able to do. But the digital simulations don't start until third. Second grade actually has modeling tools. So they are able to access the modeling tools at second grade. But third grade is where they actually begin. If you want to see, the easiest way to see them is actually to go into the elementary student app. So again, if you hit right here and you go into the elementary student apps, which are going to be right here, these elementary student apps, then you can see the different grade levels and you can see what they have. So for example, like if I'm in kindergarten, all I have are the student books in English and Spanish. But if I go to like second grade, so let's say that I go to second grade plant and animal relationships, I can actually see that I have modeling tools as well as the student books. And then starting at third grade, remember I said it was going to be environments and survival. Then you'll see that I have the digital simulation, the modeling tools, and the student books. And then, of course, if I jump to fifth grade, when I jump to fifth grade, so like let's say I do modeling matter, you notice that I have two digital simulations, the modeling tools, and the student books. Now, as far as middle school has digital simulations and modeling tools for every unit. So you actually see them that way. And some of them have multiples as well, because that scale tool will come into play multiple times throughout the units.
Another question, are there versions in other languages such as Spanish?
Yeah, so you can actually toggle between them. So the Spanish versions, like the Spanish versions of the books and the Spanish versions of the digital simulations, most of them, you know, they don't have a lot of things that have to be translated, but all of the things that can be translated are translated into Spanish.
And then we have John who asked, and this might be our last question. Will you get confirmation that you attended through the email account you signed up for? Yes, John, you absolutely will. You will get a Zoom email that will have your certificate and that shows that you attended. And then we'll also send another follow-up email from Amplify Science with some additional resources. And we'll include the demo link just so we have it there in case you didn't grab it during the webinar. And he also asked if he wants to extend the use of the simulations past the 30-day demo account, how do they contact you? Or
So
who should they contact?
the easiest thing to do is to contact their local representative. So where are you? Where are they? Because then what we can do is put them in touch, and then that way it's super easy just to kind of create those demo accounts for them.
Yeah. And if you need help, John, you can also reply to the Amplify Science email you're going to get, because we monitor that address all the time, so we can answer you there too. Oh, so many questions came through when I said that might be the last one. Is Spanish the only language that you can pick from?
Currently, yes. So Spanish is the only language that you can pick from. We actually have a multilingual glossary that's within our program, but Spanish is currently the only one that is translated in.
Does the website have the ability to read to students?
Yeah, actually everything is audio. So, and you're able to do it. If you're looking at like the books and things here, let me just share it with you. What we did was not only within the books themselves, like all of the materials are in English and Spanish, and they're all audio. So like if I'm in first grade and I want to have the kids go through their books, one of the best things that you can do is you go right up here to the 9-dot grid, and you can actually go into the library and see everything, right? So in English and Spanish, and these are all audio. I think my favorite part though is that when you click on that 9-dot grid, if you scroll all the way down to the very, very bottom, there's a thing called the Science Program Hub. And in that Science Program Hub, we actually have all the books in read by teachers. So if you go right here to the on-demand resources, you click on the on-demand resources, and then right here, you can pick your grade level. So like, let's say I picked first grade again, and I wanted animal and plant defenses. These are my books right here. These are my read alouds. So the read aloud videos are here in English, and here they are in Spanish. So if I click on these, I can actually listen to these books being read aloud.
Hi everyone, it's Mrs. Leone, and I'm from Colorado. Today, I'm going to ask that you help me think like a scientist and ask questions to figure out what some animals eat for lunch. So I'm going to read this book to you called Whose Lunch Is This? All right, let's go, scientists.
My favorite books, actually. But then if I want to see it in Spanish, I can just go over here and click on the same one. Just click on that same book. Oh, it's a different book. But
Púas, corazas y otras partes protectoras. Un manual de defensas. Por Chloe Delafield.
so,
Púas,
I mean, all the resources are set up that way.
Perfect. And since there's a lot of questions about certificates, everyone who is here live today will receive well, look at you, Ryan. You literally are going to say exactly what I'm about to say. Will receive a certificate of attendance and a recording from Zoom in the next few days. So usually it's within the next 24 hours, but it will definitely be sometime this week that you will receive a Zoom email with the recording and a certificate of attendance. And then you will receive another email from Amplify Science with the recording again, the demo information again, and links to other resources you can use right away. And let me go ahead and share our last slide. Francis, I'm going to kick you off.
There you go.
All right. Just want to wrap up. Thank you everyone for joining us today. I love all the conversation we had at the end. Francis, you did an amazing job going through these simulations. And if you want more resources from Amplify, you can find more free PD opportunities at amplify.com/science webinars. You can access free activities and guides used today in our science free resource library that we just updated at amplify.com/science free resources. This has all of our past free resources we've done, guides that we've put out. You can access it all in one place, including activities. And if you want to learn more about Amplify Science, which is where these simulations come from, go ahead and go to amplify.com/science and learn more about the program. And that is it for today. Thank you, everyone, so much for joining us. Thank you again, Francis. This was super fun.
Thanks,
Bye,
everyone.
everybody.
Was that okay?